Am I audible?
Yes.
Am I audible?
Yes.
Yes, Sonali, you are audible.
Sorry, extremely sorry. Good afternoon, all. Here we have gathered in the online to attend this 2-day international webinar.
Just a minute. Is there any other device nearby?
Yes.
There is echo.
Hello. Good afternoon, all. Here we have gathered in the online platform to attend this 2-day international webinar on development in technology, role of fiber optics and solar energy, organized by Department of Physics, Ordinary College for Women, and Internal Quality Assurance Cell, Ordinary College for Women. And I am to deliver the welcome address, I would like to request our principal, Dr. Urmila Ukil, whose in this effort has placed this educational institution in a distinct position with its own distinct features. Madam, please.
Sonali, shall I speak now?
Yeah. Madam, continue, please.
Good afternoon, everybody. Thank you, Sonali. Today, the Department of Physics and IQAC of Sarojini Naidu College for Women has organized 2 days international level webinar on development in technology, role of fiber optics and solar energy. On behalf of Sarojini Naidu College for Women, I welcome you all to this webinar. I thank the Department of Physics and IKSC of our college to organize this webinar on this very important subject of today's era. I thank all the participants to be here in this web platform. And what I'm saying that technology is developing every day, from the morning tea to the uh, device we sleep at night. Every device is developing every day, and in the COVID situation, we see that the technology we use for teaching or learning is developing, and we are supposed to use this technology because otherwise we are not able to make ourselves ready for the present era. I think the role of fiber optics and solar energy that will be very important in today's situation. And solar energy we are using every day for various purposes in our lives and in our everyday situation. And I thank the Department of Physics and IPSC for organizing this webinar on this very recent topic. On behalf of the college, I express my gratitude to Professor Jashankar Rai for giving his time, valuable time with us and giving his consent to speak in this webinar. I thank all the participants who are present in this web platform today, and I wish today's webinar to be a grand success. Thank you all once again.
Thank you, Madam, for your warm and inspiring address. Now, to deliver the inaugural speech, I would like to request our IQAC coordinator, Dr. Sudeshna Chatterjee, whose dedication and enthusiasm has made it possible for this institution to arrange a significant number of webinars and seminars on various topics at national and international levels every year. Dr. Chatterjee, please.
Thank you, Sonali, for these kind and slightly overrated adjectives. I am not, in fact, I don't feel eligible for such kind words. Anyway, uh, I welcome all the participants of this webinar, and I have heard from abroad also, and our distinguished guest, today's speaker, Dr. Joyshankar Rai, for being present here and for allotting some time of busy schedule for us. In fact, our college um, um, has been uh, somewhat old because we have crossed 66 years milestone, but the majority of our members who are our students are really around 20 years. So we are simultaneously old and young, and in fact we are continuously trying to make our students socially conscious, scientifically eager to know any new knowledges and any new information, and to make themselves healthy members of the society. And for this aspect, I am very much thankful to Professor Rai, Dr. Roy, because today's topic is a very interesting one. Since the last decade, we are every day we hearing the word fiber optics, and whenever we cross the road and whenever there is something going on under the roads, etc., we hear that the fiber optics are being planted by these Reliance, Zero, etc., etc., some other agencies. But actually, what do these fiber optic materials do in our everyday life, and what is the technology behind it, and how can we use this technological knowledge for our own advancement? It is not known to us, and I think that today's lecture will be much helpful for our students as well as for us, the older people. And once again, I thank all the participants of this webinar and welcome them, and our my colleagues in the Department of Physics of this college who have organized this webinar. And I hope that all of us will enjoy uh, these 2 days webinar talks very much. Thank you once again.
Thank you, madam, for your encouraging speech. Now, I would like to request Dr. Enakshi Guru, Head of Department of Physics, to share with us the motivation for this webinar. Dr. Guru, please. Dr. Guru,
Good
please
afternoon.
join.
Yes, am I audible?
Yes, audible.
Good afternoon. On behalf of Department of Physics, I welcome all our respected principal, IQAC coordinator, invited speaker, Dr. Joy Shankar Ray, my colleagues, and all participants from various parts of India. Our department has arranged 2-day international webinar whose topics are related to fiber optics and solar energy. All we know about these topics, very few basics about these topics. Like fiber optics is widely used in telecommunication service. It is used for long distance and high performance data networking, etc. In our undergraduate syllabus, students usually get preliminary idea of fiber optics, whose fundamental idea depends on total internal reflection. They know very few about pore cladding, total internal reflection, numerical aperture, just basics of this fiber optics. I'm sure from today's lecture, they will learn more from our respected speaker. And tomorrow's lecture is on solar energy, which also plays an immense role in modern era. Solar technology converts sunlight into electrical energy, either through photovoltaic cells or through mirrors that concentrate solar radiation. This energy can be used to generate electricity or to be stored in batteries or thermal storage. It has wide application. It is alternate source of electricity also. Tomorrow we will listen about this, but for today we will learn about more details of fiber optics. Thank you. Over to Sonali.
Thank you, madam, for your illuminating overview. Now, I would like to request Dr. Monisha Pal, Associate Professor of Department of Physics, to conduct the technical session. Dr. Pal, please.
Thank you, Sonali. Am I audible?
Yes, you are audible.
Yes.
Very good afternoon, everyone. Once again, I welcome you all in this today international webinar on development in technology, role of fiber optics and solar energy. On this occasion, our first speaker is Dr. Jaishankar Roy, Senior Research Scientist, Center for Optics, Photonics and Lasers, Laval University, Quebec City, Canada. Dr. Roy is expert in the field of material science and engineering. He works on nanomaterials, glass and glass ceramics, optical fiber, and prospective applications of materials. He has profound knowledge in optics and photonics. However, as a customary and for the sake of audience, let me introduce him briefly. Dr. Roy completed his PhD in physics from University of Kolkata in the year 2016. After completing his PhD, he joined as a research associate, Sif Nadar University, Noida, and subsequently moved to Dream Institute of Technology, Kolkata, as an assistant professor. He was postdoctoral fellow in Sao Paulo University, Brazil, during 2018-19. He was also postdoctoral fellow in Laval University, Canada, for almost 2 years before joining his present position in the same university. He has published around 25 research articles in highly reputed international journals. He also delivered many invited talks in national and international conferences. He is working with many research groups in Canada and Brazil. With this brief introduction, let me invite Dr. Roy to deliver his lecture on Perspective of Fiber Optics in Modern Technology. Dr. Roy, please.
Yes, can you hear me?
Yes. Okay.
Thank you very much, Dr. Paul, for introduction about myself, my career, my professional career, all this thing. Thank you so much. I'd like to thank you, head of the Department of the Physics and all faculty members of the Department of Physics for organizing this beautiful 2 days webinar and inviting me to deliver a lecture on fiber optics. And also I'd like to thank my master's classmate and my friend Dr. Obdagiri for letting me know about this conference and inviting me to deliver a lecture on this topic. So anyway, just a minute, I will share my screen to deliver my lecture.
Thank you, Joy.
Oh, you're welcome. Just a minute, I'll. Yeah. Yes, can you show me my screen?
No, yes.
No.
Yes.
Yes. Is yes or no?
Okay, okay.
Can you see? It's okay?
Yes, yes.
Okay.
No problem.
Thank you. Oh, it's okay. Thank you very much. So, okay. If during my presentation, if anybody any doubt, you can stop me and you can ask me any questions. Okay. And it is online platform, no, something, some problem may happen. So if you feel any problem, so just let me know. Okay. So, okay. So today I'm going to discuss about perspective of fiber optics in modern technology So you know the modern technology is rapidly growing, especially with fiber optics, and fiber optics is capturing in different field of research in scientific field, in technological field, and also in our daily life. So I will discuss about that in details. But before going to discuss about that, let me introduce my institute. Okay, you know, this is a okay. Just a minute, I'll trying to find out the laser source here. Oh no. Anyway, okay. So this is the map where this is the in Canada, in the northern region is called Quebec, the province, and we are residing in the Quebec city in the province of Quebec. It's a beautiful city,
Uh,
and and
Sorry, Joy.
yes,
Your slide is stuck up at one point. It is not in presentation mode.
no,
No, sides are
Slide.
not changing.
now it's
Is
okay.
it
No,
No, it is
is
not
it first
changing.
slide?
oh, mhm.
I think you will have to
It's
put
okay.
it
Can
in
you
a present.
see?
No, 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 not yet.
Oh,
I think you have to share entire screen.
Yeah, yeah. Only one slide. Title slide is only showing up.
just a minute. I'll check and I'll just stop and starting again this slide. Okay. No. It's okay. Can you see? No. Hello? Hello?
Yes,
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 Please check. It's changing?
yes,
it's
No,
changing.
changing.
It's
now it
okay?
is okay.
Okay,
Yeah,
okay.
yeah.
Thank you. Okay. Okay, so let's continue. Yeah, this is we are situated in the northern part of the Canada. It is in the Quebec province, and we are in the Quebec city within the Quebec province. So it's a beautiful city. It is World Heritage City, and the left corner, down corner, it is Laval University campus. It is a very big campus. We have each department like science, engineering, and arts, commerce, everything. So it's a big university, and we are, and this is the right corner. This is our institute. It's called Center for Optics, Photonics, and Laser. So, okay, before starting the application of optical fiber, let's little bit talk about what is optical fiber, how it works. So, you know, optical fiber is basically a very transparent and flexible cylindrical, basically cylinder like our human hair. But depending on application, we fabricate this optical fiber with various thickness, maybe sometimes 200 micron, sometimes 400 micron. It depends on application. But this cylindrical rod basically made with glass or plastic. Plastic, there are different kind of plastic polycarbonate, polystyrene. So depending on application, we fabricate this with different material. And basically, what optical fiber does? Basically, optical fiber is guide the light signal through this cylindrical optical fiber to send the maybe signal or something else, depending on our application. The two main parts of the optical fiber is core and cladding, but when we fabricate this optical fiber for commercial application, it has several parts like core, then the cladding, then we put another coating to protect the fiber. especially if we fabricate glass fiber. So, glass is very much fragile, so anytime it can break. So we coat some another plastic material just to cover it, and such that it can be very flexible without breaking from any point. So, and finally we put some outer jacket just to protect the fiber and for longevity. And you see this the right corner, this below the figure, the optical fiber bundle. This kind of bundle basically is designed for communication system, especially when we like internet connectivity or even telecommunication system, we use this kind of fiber bundle. There are a lot of fibers. It's composed inside a big plastic jacket. So what is the basic principle actually for fiber optics? Fiber optics, basically, this is one and only fundamental working principle is the total internal reflection. So this total internal reflection will happen only for certain case, especially if on the undergraduate student. Basically, they know how when the light is enters from one medium to another medium, there is a different kinds of phenomena can happen, like reflection, refraction, transmission. So when the light is going for some higher material to lower medium, so then there is some special angle called critical angle. After that, if you go beyond this critical angle, it will be reflected back in the same medium. That is called total internal reflection. And for this total internal reflection, we need to make the optical fiber core and cladding, and this core, repetitive index of this core should be always higher than cladding. In this case, the light will be guided, light actually be total internally reflected inside the core, and it will be guided through the fiber, and we can send the signal, especially in the form of light in different places. So another thing is that numerical aperture is not like that. We'll put any light from any angle, it will be totally internally reflected. As I told you, it will follow the Snell's law, and it will be the ray should be incident on that core, such that it should be incident angle should be higher than critical angle. And there is to discuss about this, how much the angle we can cover to inject the light inside the core of the fiber. So there is one parameter is called numerical aperture that is very much important for fiber optics. Especially this parameter actually defines the quality of the fiber, because and this quality of the fiber, that means how, especially you see from the equation, numerical aperture, it depends on both the repetitive index of core and the cladding. So from the equation you can see, if we play with repetitive indices of the core and clad, so we can change the numerical aperture. And numerical aperture is actually sine inverse of numerical aperture is the angle. So total angle is called the acceptance angle. That angle is allowable to the core of the fiber, such that it can be transmitted for the long distance to the optical fiber. So you can see this picture in the right side. There's a small video. Actually, you can see the laser light is put on these are especially in the kind of glass rod, but here glass is repetitive index is close to 1.5, 1.4, something like that. So and it is outside is here. There is no core cladding, but here actually clad itself is the air. Here repetitive index of air is 1, so it is glass repetitive is higher. So when you put inside light injected through a green laser inside the rod, it is actually in a certain point it is going to be happen totally internally reflection. So and the light is guided to this rod. So this is the basic working principle, that totally internally reflection of the light inside the core of the fiber. So now this is the thing we know about the little bit about the fiber. What is the fiber? What kind of material we can use? But there is a technique how we prepare the optical fiber. This is the instrument. It's called fiber drawing tower. we have this institute in our institute. Is a big instrument. It is on almost 15-meter height. That means almost close to 3-4 story building. It's a very big instrument. They have a lot of different kind of equipped. That means we have a lot of sensor. We have a lot of coating system to coat over the fiber. You can see the right hand side. There's a picture actually where we put the glass rod. As for example, if you want to draw the fiber with glass as a core, then we need to put the glass rod here, actually in the top of the optical tower instrument. We have some holder. We put the rod depending on your type of fiber. Maybe you can put the glass rod or any plastic rod. So here I'm just giving one example. We put the silicate glass. Silicate glass is highly pure silicate glass. Especially nowadays, also in most of the cases, we use silicate glass because of the high purity, low loss of the optics light. So we use this silicate fiber. So here we put the silica rod over the fiber tower. And here actually we have this very high temperature furnace. Depending on your application, we need to melt it. There is one temperature is called glass transition temperature. Glass transition temperature is the temperature in which anything, not only glass, is called glass temperature, but it doesn't mean that it happens only for glass. It can happen for any plastic, any other material, especially for plastic and plastic kind of material, amorphous material. In certain temperature, it just started to melt. It's not melted completely, just started to melt. Actually, to draw the fiber, we need to put this temperature just to be started to be melt. Then we have some pumping system. We just draw it, we just pull it, and the fiber is coming from the system. And there is actually, and depending on our need, we have different kind of die, such that the fiber will pass through the die, and we can control the diameter. Depending on our application, we have our system that we can draw minimum of 100 micron and maximum of 600 micron. Okay, the thick core. And then we have you see the drawing tower, they have different platforms, different step. We have different coating system, like we put cladding, then another plastic coating, then jacket to draw the fiber, finally optical fiber. Anyway, so let's talk about the application of fiber optics. So fiber optics actually nowadays is being applied in different field, like especially and mostly we use in the communication system, and the lighting, and the sensor, environment, energy, and medical system. So especially since this communication, medical, lighting, sensor, this is conventional application. That means when the fiber optics actually started the research, or it's found to be a good promising material for different technology. Actually, we used to apply in communication system first, then medical, sensor, lighting, all these things. But these two most recent part, the people are doing research nowadays, especially last maybe before they started before few years, energy and environment, and especially environmental application is quite new one. It just maybe started 2-3 years before using optical fiber. And so basically I'll give a brief overview regarding other conventional application, and I'll focus on some energy and environmental application of optical fiber. So it's for optical fiber for lighting. We generally this kind of small plastic fiber, actually we can see anywhere in the market, made with plastic fiber and put in the coupled with some LED, and it gives some beautiful color. But nowadays people are using the optical fiber for decoration, lighting, interior decoration, kind of lighting in hotel, even in the house, you saw there is a few restaurants I saw, they make this kind of fiber optics, they put in the ceiling, and they make a model with coupled with LED, and they are giving some beautiful design. And in the right side top, you see the like kind of is kind of tree make with some optical fiber. It's just for decoration. It looks very beautiful. There is one big company in China. They are making this kind of product for interior designing. Even in this, see the last picture in this kind of spiral and the like a galaxy, all these things. So nowadays they are preparing kind of module integrated with LED and fiber, optical fiber to make this kind of lighting interior for interior designing. So it is very interesting, and it is a big market. It is growing, so people are showing interest. So fiber optics in lighting actually it became a profitable business for the company. And next one is optical fiber for communication system. Communication system, this is actually oldest application. When the people discovered the optical fiber, actually it was first communication system. They are trying to send the signal from in the form of light from one place to another place. Then actually nowadays actually we are using a lot of internet, TV, all this thing is because of optical fiber. Because it is, you can understand now, it is light. Actually, any information, any data is sending in form of light, and velocity of light is very, very high. So there is a with a fraction of second you can see it. So communication system is nowadays all in the optical fiber, and still optical fiber it depends on the kind of optical fiber. No, there is some optical fiber there may be lost, so speed become less, and so people still are working on that to modify special kind of fiber to send the signal more speed. Especially we know in our department, in our institute, actually we have some people that they are doing only on amplification system. That means we are sending the signal, but they are trying to amplify the speed so that you can send the signal with more faster. Even there are a lot of things I'm not going to discuss about that. There is a single mode fiber, multi-mode fiber. Then it depend on channel, how much channel you are using. You can for example, for multi-mode fiber, you can send the different kind of signal at the same time. So people also working on that. This is not too much developed right now, but still people are working on that to find or to discover special kind of fiber with multi-mode system that can send several data in the same time with more speed. Now it is another important application of optical fiber is that for medical application. Medical application is also quite new, but still you cannot say new, because for many years the people are using optical fiber in case of medical diagnostic. Especially light therapy, you can say is quite a newer one. If something happens inside our human body, so people are sometimes you need some laser therapy, or also people are using LED therapy just with high LED power LED. So they are putting in the fiber optical top of the optical fiber. They are putting inside the body, and they are sending the signal, light signal from outside, and they are doing therapy. It's called light therapy. And similar way, microsurgery. The people is very much common nowadays. Is the microsurgery. They put in actually basically is nothing but an optical fiber cable, and they put a very small knife or forceps, all the thing on the top of the fiber bundle, fiber, and they put some generally LED. They put sometimes low power laser, otherwise it can harm the interior organs. So that's why people use either low power laser or especially LED on top of the fiber, and they put inside the body, so they can image, they can see inside how they are doing the microsurgery. They can record in the computer the total surgical process, all this thing. and is very much common nowadays. It is imaging of the inside of our organ, inside of our body, like endoscopy, colonoscopy. Endoscopy actually to image the inside of our digestive system, like stomach, all this thing, to take the picture and to find the damage inside this organ. So fiber optics actually in the field of medical, they give a new perspective for doctors, that they can do the surgery easily. Is a shorter, in this case, in this kind of surgery, shorter recovery time. So it is very much helpful for other invasive surgical methods. So, and it is in under research, and people are doing so that it can be applied in more and more in medical applications. Another important application of optical fiber or sensor. Sensor is nowadays, is very much common. We know the sensor is everywhere. That means even your door system, even your somewhere, even in the office, university, everywhere they are putting some kind of sensor that you can sense the whether is closing the door, opening the door. This is just an example, but there is a lot of this kind of sensor now we are using with optical fiber. Here I give some example, like a temperature sensor, like a mechanical sensor. Mechanical sensor, that means it can measure the stress, strain of the body or something, and the kind of chemical sensor that it can sense if there is a chemical reaction. So some chemical present is there. Basically, I'm giving just an idea how it works for temperature sensor. As for example, you see, especially is for plastic fiber is very much effective for that, because if there is a high temperature, the plastic fiber is going to deform. Then with this deformation, when you will get the signal of light, so you can understand that there is something happening, and there is some protocol or some module that on that thing you can understand how much the temperature, or you can measure. Same thing like a chemical sensor. When the light signal is going, if there is some kind of chemical that can react with the light, so it can obstruct the light, or it can absorb it can absorb the light. So you will get the different kind of signal. So from the spectrometer, you can check and you can identify the chemicals present there. And this I just give an example how it actually works, like a chemical sensor. So it's just example. So in different different cases, we use the special kind of optical fiber, depending on application, depending on need. We fabricate different kind of fiber for this kind of sensor. Especially in our group also, we are developing one kind of this kind of sensor. Is called, you can say, kind of mechanical sensor. Is made with some plastic fiber. So we are making some wearable sensor. Wearable, that means this is the fiber, but you can put you can wear it with some your clothes, maybe in the t-shirt. You can just put there, and during your breathing, your movement. So this fiber, it will expand, or it will sense the temperature. So you can check remotely with that your muscle strength or your heartbeat, all these things. So it is developing. We just, in our research group, they actually just they are published one patent on that last maybe 2 years before, but still they are trying to develop it. They are trying to put some Bluetooth with that system, so that you can monitor your health system from far. Anyway, this sensor, this optical fiber sensor, is also growing field, and lot of people are doing research on that field, and that's it. Now, as I told you, all these things are basically conventional. That means the people thought about that application. That people, when the fiber optics is discovered, then people gradually started to think all this of application. But this in the field of energy and the environmental application is quite new one. It just people just started to think about that. So here I will show you the how we can harvest the solar energy using optical fiber. And why the people, so not only our research group, in the people from the worldwide, they are now investing a lot of time to solar energy, because global energy demand is increasing, and it is expected that to be doubled in 2050, and all other fuels like normal fossil fuel, coal, gas, etc., they are going to empty or they finish soon. No, so that's why people are looking for alternative energy source, and in this case, solar energy is the most abundant source of energy. So it is people are showing interest on that. So, but people nowadays, a lot of people are doing research on solar cell, photovoltaic cell, some solar heater. There people have made some solar heater directly. You can absorb the heat. You can use it the application. Like a solar cooker also, you can cook your food using the solar light. But another most important thing that I am going to discuss is called daylighting system. Daylighting is that you will capture the sunlight, and you will use the sunlight in your office, in your house as a light source. So this is the daylighting system. Why people are focused on daylighting system? Because almost 40% of the total global energy is consumed from the lighting system. Lighting, that means when you inside the office, inside the building, inside the house, we use the light. So almost globally 40% total energy is used for these buildings. So nowadays people are thinking how to use this energy to use for daylighting system. Especially for solar cell, they can storing it is good, solar cell, but solar cell is expensive nowadays. Still, the people are doing research, is expensive. It cannot so much cheaper. So people are thinking with different technology. So here we will discuss about the optical fiber bundle, how we can harvest the solar light directly in our house or office. So this is not using optical fiber. This is it's called optical pipe. People are thinking how to use this solar energy. The people made some kind of parabolic reflector. They capture the sunlight and sending through this cylindrical reflector system to the house. So this is also quite a new one. People using this one, but it's not too much effective actually. So now then people were thinking about how to move the solar light or harvest solar light and send it to different places with easily. Then people thought about optical fiber, because if you make the big bundle optical fiber, it is very much flexible. You can send the light anywhere. But you see, this is one of the recent work actually. People say they published in 2017 actually, but they use the PMMA. It's called is basically PMMA is the plastic fiber, polymethyl methacrylate. It is a plastic. So they used it, and they use kind of, you see, like a antenna, like we use in the dish antenna. No, so they say this kind of dish antenna, they put them small mirror top of the dish antenna. So when the sunlight incidence on that reflector, the reflector, the light reflected, and they to heat sunlight. So they it started to melt. Sunlight
Dr. Rai?
Yes.
Can't hear.
Okay. Hello, Dr. Rai.
Hear me?
Yes,
Yes,
now
yes.
you are audible.
Okay. Okay. Okay.
No audio is coming.
Second.
But sound is breakable. Probably.
Right, you see the last figure, it is actually inside the building. You can see the light. Basically you are this sunlight from the directly you are using inside the building, maybe in your office or in your house. Anyway, so we actually developed this. As you saw, as you saw in the last slide, actually, they some people did the research, but this is not so much powerful, not so much efficient. And so we developed this system. Actually, we installed this in Brazil in 2000, I think 20. Yes, we designed this system. This is very much strong instrument, and it can concentrate a lot of the sunlight. It can send very high power. I'll show in next slide. But this thing is very much sophisticated. And we put some solar sensor that it can move with sun. It can track the sun, and it will move the sun. This system will move with the sun automatically. So all the daytime you can capture the sunlight, and you can send the signal anywhere you want. So what about this system? You use the primary mirror. This mirror actually we used just to concentrate the sunlight, because if you just go outside and put the fiber bundle, you can capture the sunlight, but it will not be so useful. Not useful in that sense. The power will be very less. So to get the high power, to deliver the high power, we actually designed this concentrating system. It is in this actually idea I got from the Newtonian telescope. Newton telescope. Actually, when we studied in the my masters in St. Xavier's College, actually studied about the Newtonian lens, all this thing. How to take the picture of the galaxy or moon, something like that. Actually, I use this. Uh, idea to develop this system. It is kind of telescope. It has two mirror. One is a big mirror, 75 centimeter diameter. This is called primary mirror. You see this one. Another is secondary mirror. So actually sunlight, when incidence on this primary mirror is focused to the secondary mirror, is here, the flat mirror, and it is come back to the top of the fiber bundle. So it is very, very high concentrated sunlight. And in this case, the optical fiber we use the core of the fiber is the glass fiber. Is refractive index is 1.45, and we use the low index refractive index cladding is 1.37. So you can see the refractive index is less, the cladding, so in quite different. So we can guide the light to the fiber, and we put another protective polymer just to protect the whole fiber to maintain the good flexibility. Is refractive index 1.53. Anyway, for this system, we make the fiber bundle with 460 pieces silica fiber, and diameter was 600 micron. And And you see, this is the more highlights thing that we have developed. Develop the system. You see there we put the solar sensor just to track the sun position. There's a few two motor 1 and 2. One is to rotate horizontally, another one to rotate vertically, just to track the sun properly. We put on the electronic system. There's some PLC, then is just to collect the data through the solar sensor, just to track the sun, all this thing. Yeah, this is the system. And the third one is the joystick box. Is a kind of controller of the solar tracking system. So we can manually also we can move it. Here we have different system. We will put the automatic. It will track the sun whole the day, and you will get the light. Otherwise, you can do it by manual as well. You see, this is the principle of the. I sorry to tell you that we put the name is EcoSend. If you search in internet, you can see this is called EcoSend. We give the name actually. Working principle that I told you, so solar light falls on the primary mirror. It is a parabolic, then reflected back to the secondary mirror here, and then reflected back to the top of the fiber bundle, and fiber bundle is collected the huge energy. You see there is in the right one there's a picture. The another part of the fiber bundle, another end of the fiber bundle, you see there is a very high light you can see, but you cannot justify from this light, because we take the picture in the daylight actually. So anyway, and this is the fiber outlet actually, from where you can get the high concentrated sunlight. We measured this performance of this EcoSend to how much light you are actually getting. So we actually put from one whole day just to check in a different time. We started from morning 8 to 5 p.m. just to check the efficiency. First one you can see this is the normal solar irradiance. Irradiance, that means is power of the solar is milliwatt per centimeter square. You see we got the maximum on that day. This instrument we built here in Canada, but we set up in the Brazil. There is a very and we measured all the data actually there in Brazil. So you see from first graph is 75 milliwatt per centimeter square, or 750 watt per milliwatt per meter square. This is normal solar index, 75. But you see from our system, you are getting almost more than 7,000 milliwatt per centimeter square. You see, so almost it is close to 1,000 times higher than you are getting. But still here, this is our first experience. First we set up this instrument. We didn't know what will happen. That's actually we did not coat the primary mirror fully, 100% coating. We actually put some aluminum coating and then silicon coating over the primary mirror to reflect the sunlight properly. So we coat is 50%. So if we coat it 100%, so energy will be more and more higher. Anyway, you see, this is just I measured just to propose our system, just to understand our system, how good it is, or whether we can use it as a commercial purpose or not. So we did some experiment. The light intensity we compared with the normal light intensity that is available in the market, like LED or like a normal incandescent bulb. So you can see from here. So luminance, I measure actually flux, basically light illuminance. You see from the EcoSend we are getting 35,800, but when we are using 160 watt incandescent bulb that we use in our household, basically only 44. If we use 15 watt LED bulb, we know everyone that is quite good than incandescent bulb. So it is 239 lux, but now if we consider our system with this commercial bulb, you see it is actually 813 equivalent. Our system is in that present condition with 50% efficiency, you see 800 equivalent of 813 60 watt incandescent bulb, or almost 150 15 watt LED bulb. So actually this is quite powerful, 150 as well as 150, let's say LED bulb, 15 watt LED bulb. So 150 LED bulb, it can give a lot of light. So maybe small office, small building is enough. So this is the schematical diagram that we proposed. So if we build this kind of system and install in the top of the building, on the roof of the building, so we can distribute the optical fiber in different rooms, or in different offices. So we can supply the light, daylight directly. And basically this is very much important, especially everywhere with this kind of sunlight, using sunlight directly. The research actually suggests that the normal artificial light that we use, there is sometimes there are a lot of is kind of harmful to our health, and especially in here, not only our Canada is like Canada, there are some countries that very much cold, like in our country, Canada, actually 4-5 months is totally cold, and we cannot see the sun properly. In this case, actually people suffers from psychological sadness due to this kind of light, artificial light. So in this case, sunlight, this kind of system, it will be helpful. There's some research I didn't show here. They are telling that the different kind of health disease related to artificial sunlight. No, sorry, artificial light. Anyway, so we not only that, to commercialize this kind of system, we need to study the performance. That means how long it can last, because to develop this kind of system is actually costly. So we need to know the efficiency, number one. Number two, the longevity, lasting, how long it can last. So actually, for the experimental purpose, we studied actually during 1 year, from 2018 August to August 2019. Actually, you see, we observed a 23% degradation. That means efficiency decreased by 23%. It may happen for different causes, like this system actually, you saw the picture, it is in the open ground, so there are a lot of dust particles. They put they covered maybe on the mirror, both the mirrors. Maybe there be the degradation of efficiency of the fiber, but mostly we observed that due to the dust coating over the mirror, because we tested the fiber, it was okay. And especially, I told you at the beginning that we use the highly pure silica fiber. Now, silica fiber is very much effective. And one thing I forgot to tell you, actually, what is the importance of this work beyond the another work that were in the market, the people already reported in the literature. They use normal plastic fiber, as I told you, that it will melt. If you use the highly concentrated light, it will melt. And if we use another glass also, sometimes it is difficult to tolerate. Here I use the silicate fiber. Silicate fiber, it can tolerate up to 2000 degrees centigrade. If you heated it up to 2000 degrees centigrade, it will not going to melt, because of silica is melting point almost 2200 degrees centigrade. So that's why we use the silicate fiber here, and it can long last. And that's why people also use silicate fiber for long distance communication system. Anyway, so this is the daylighting system. That means quite new field, that you can harvest the solar light and you can use it for our household or office application. And another challenging application of optical fiber is environmental application. Environmental application, that means generally like air pollution, water pollution, and like this. So it is quite new field that people are still developing. We are doing a research on that. In this case, I'm going to discuss another scientific term is called photocatalysis. Photocatalysis is the basically how can I say, is the photocatalysis is the catalysis, basically, it's difficult for physics student, but chemistry student, they know the catalysis, the acceleration of a reaction. But here the photons is the accelerator. In presence of photon, if you put some semiconductor, I'll show you in detail, but if you have some semiconductor, and then in presence of light, it will be accelerated certain reaction, and it can be used to degrade the pollutants in the water. It can be used to reduce the carbon dioxide in the air, and also it can be used for water splitting to generate the hydrogen and oxygen from the water. Anyway, so here how we can use this fiber, optical fiber. So we need to fabricate the, as I told you, special kind of optical fiber plus called photocatalytic fiber, and coupled with lead or laser, we can use it. Another way that I discussed before, the EcoSen, that we develop this kind of system. We capture the sunlight. If we want to use the sunlight, so capture the sunlight and put on the system using semiconductor. I'll show you in the semiconductor and water system, so you can clean the water. So okay, here actually one slide I forgot. Okay, so yeah, I can explain a little bit about the photocatalysis process. So you have some semiconductor that it has certain band gap. Okay, I put here the BiVO4 is a bismuth vanadium oxide, the nanoparticle actually. BiVO4, you can use the zinc oxide, titanium dioxide. There are a lot of semiconductor that is very useful for photocatalysis process to degrade the pollutants in the water, or to reduction of carbon dioxide in the air. So you see the process is that the semiconductor, it will capture the maybe sunlight or any light that wavelength should be comparable with this band gap of the semiconductor. As for example, BiVO4, it has band gap around 2.3 or 2.4 electron volt. So comparable with this band gap, when you will put the light with this compared to this energy, so it will absorb that light, and the electron will jump from valence band to conduction band. So there will be the holes in the valence band and electrons in the conduction band, and these electron and holes actually there's some internal mechanism. I'm not going to discuss in detail, but there's a mechanism that oxygen with this electron with the oxygen, they react and make super oxide radicals, and also hole with water, they produce hydroxyl radicals. And these radicals, their redox potential is very high, and they degrade. Like I saw here, methylene blue is one kind of pollutant in the water, or it can degrade the oxygen, carbon dioxide, similar process. Anyway, so why I'm talking about the photocatalysis process, and the people are doing research on that thing, So basically, photocatalysis process is the ambient condition reaction. That is normal temperature, normal environment, it can happen, and it is very useful because there is no secondary pollution. Because especially I'm focusing on the water treatment. There are a lot of technology that people are using to clean the water, but every time, as for example, that our household, we generally use some kind of filtration kit, but you see after certain time, there's certain lifetime, that means there's a capacity. Now after that it cannot work, so you need to throw it. So basically, maybe it absorbs some pollutants over there, the filter, but after that you need to throw it. So you don't to throw it, but you need to throw it somewhere. But from that thing, then pollutant from this your kit, waste kit actually is going outside, and it will pollute the water anywhere, like your pond, lake, anywhere. So nowadays people are very much not curious, actually very much showing interest on the water treatment because of pollution. With the growing population worldwide, there are a lot of industry, so water pollution is going to increase every year. So people are focusing how to clean the water with some good scientific way. That means there is no secondary pollutants, there are no harmful kind of sustainable. No? So yeah, in this case, the photocatalysis is, so people are telling, oh, it's good because there is no, you can degrade the pollutant directly. There is no secondary pollution, and you can use the light. Is more green. If you use the sunlight, it will be more green system. More sustainable. This is just for your information, though. I told you, Bismodhanam photocatalyst, you see like this when you need to prepare some nanoparticles, or you can buy from the market. You see this is the nanoparticles actually prepared in our group as well. So it's very, very fine, maybe 50 nanometer diameter, kind of spherical. And if you check the absorption, it is 448 nanometers. So that means in the visible region, so people can absorb this nanocatalyst can absorb the sunlight or any visible light, and you can use it. And this is the one example of wastewater treatment that using EcoSense that I told you. So on the graph you can see, if you change the power of the light that you are focusing on that system, so you are getting higher degradation rate. Degradation, that means here we use some just for example of some dye you used. The dye generally used to color our clothes or different kind of thing. So yeah, so it's good to use our system for system. You see, this is the just for your better understanding. Is so you see, like colored water become white after certain time, so you can clean the wastewater, especially for industrial wastewater. And this is our EcoSense actually that we published last year in very good journal. Anyway, another thing is photocatalytic optical fiber that we can make directly. You can put some I told you we need some semiconductor, but optical fiber itself is not a semiconductor. Silicon is there, but it will not work. But that's why we need some semiconductor. We need to put over the fiber certain semiconductor for photocatalysis process. Here I saw one thing that we coated. There one nanoparticle called cadmium sulfide is very much effective for photocatalysis. We coating over there and make the small bundle, and you see the coating here in the right side corner picture, the ACM image, scanning electron microscope image. You can see the coating of the CDS over there. Okay, and here how we set the experiment actually. The experimental setup. We put some that we this fiber bundle of fiber we hold in somewhere, and we put the laser source there, and we put the laser light on the top of the fiber bundle of the fiber bundle. So light is going, and it's difficult to see. Actually, we put some glass tube here containing the water with blue color, so it's going to degrade. If we use a single optical fiber, its degradation is less, but if we use the bundle, so it's going to be faster. This is another way. What we did actually, we're drawing photocatalytic fiber directly. That previously I told we are just coating. It is very simple process. This is a coating. You make some nanoparticle solution and just coating. There is some instrument we use. It's called deep coating automatic system. We use it, but here I'm telling another different technique that you can draw the optical fiber directly with the nanoparticles coating. We bought the zinc oxide nanoparticles, and I saw you before the first few slides that we have big optical fiber tower. So in that tower, when we draw the fiber, we have different coating system. We put the nanoparticle solution there and coat it over the fiber. And you will see the right hand picture, second one. You see we made the fiber bundle using this, and we were putting some laser source on the top of the fiber bundle. Okay, and you see you can clean the water treatment. I'm not going to discuss details, but yeah, you can clean it. Anyway, so this is the last slide. Actually, I want to conclude with this presentation. So fiber optics is as I told you, the rapid growing technology in various fields. People are trying to develop the technique, fiber optics techniques, to more and more, and we hope the researchers hope that it will make our life more easy in near future, and it will be more sophisticated for each and every field. And especially, as I told you, for energy environment, I hope it will do some remarkable advancement such that it will be a better future for everyone. And finally, thank you very much for all of you for your kind attention. And please, if you have any questions or if you doubt, please, you are free to ask me.
Thank you very much, Dr. Rai, for his excellent presentation. You explained optical fiber from basic principle to vast application and current research, and how optical fiber is used in medical sciences to harvest solar energy, environmental pollution, and to clean wastewater, and photocatalytic optical fiber. So we are very grateful for sharing your thoughts and experience with us. Now it is time for question answer. So participants, please ask question, and our speaker is ready to give your answer. Okay, please ask question, participants.
I have one question. Like nanoparticles are used in the coating layer.
Yeah.
What is the advantage of that? Coating is the outermost layer.
Yes, that is the thing actually. This good question actually, I didn't tell you, but it's very clear, good question. Actually, in this, if we coat the nanoparticles outer layer, this is the actually inverse application of optical fiber. Inverse, that means in normal case, as I explained you, so optical fiber works on total internal reflection. No, so light will be guided through the interior core of the optical fiber. Here actually, what we are doing, negative application. That means we are coating nanoparticle outside, then refractive is higher than the core. Okay, core maybe we use some plastic or maybe glass. Is refractive is higher, so light will not be guided. Light will actually come out. Okay, I think I saw one diagram actually when light will fall from core to the surface. So light. Some light will be maybe internally reflected or internally transmit to the second layer cladding. In our application actually you need light to come out and to hit the nanoparticles, because the nanoparticle will absorb the photons, then it will create electron and hole, and it will interact with the water. Okay, so nanoparticles should be in contact with the water. That's why actually we put the coating outside of the fiber. You are right. In this case, one disadvantage is that you cannot use the long fiber, because there will be a lot of light loss, because we are sending the light, we are not guiding the light, we are basically sending outside of the fiber, the light, so gradually it will decrease, and after some time, maybe as our case, I saw after 20 centimeter of the length light traveling, but after that it will going to be finished. Is it clear?
Thank you. I have one more question. Like
it's okay.
solar cell and solar heater, you are using fiber optics.
No.
What will be the cost there?
No, solar heater is another thing. We are not using for optical fiber. I gave one example how the people are using, but solar cell heater, I can tell you that we can use as a heater, but that system I told you, I saw you in that we did when we capture the sunlight and sending to this fiber bundle. I told you is almost 1,000 times higher the normal sunlight. As for example, if you go in the bright sunlight, you will stay there sometime, you will feeling hot, in your skin, especially in the summer in the India, you can feel too much hot, So just consider that light that we are sending to our system is 1,000 times higher, so it will generate a lot of heat. So we did not use this system as a for heater, but a lot of people I know in China, also Brazil, we have one research group, they are doing this thing. They are capturing the sunlight and they are using as a solar heater. They are using to melt some polymer or some kind of thing.
Thank you. And for the core, we are using glass, that is mainly silica.
Yes.
What type of glass is this? This is Corning glass or? because it should be costly enough.
Yeah, very
Like
costly.
effect free
Because
and all.
yeah, no, it's not, and it's very costly because we eat pure silica. As I told you, for our application, actually, we need very high temperature. As I saw, we are concentrating the sunlight. This is very powerful, so it will melt. That's why we use highly pure silica. It is expensive. I told you, this instrument that I saw you, we invest almost $10,000 to build this system. Okay, because not only fiber bundle, the fiber bundle is expensive. I think we spend actually fiber actually difficult to predict the cost because we made it here in our institute. But if you want to buy, I think it is $2 per meter. So it is expensive.
But we have found few toys like that. They are using fiber optics. That is very cheap.
No, that it depends on which kind of fiber they are using.
Okay.
If you use the plastic fiber, I'm telling no, it's 10 cent per meter, only 10 cent. You understand? Where the silicate fiber is $2 per meter, here only 10 cent. So it's very much cheaper, plastic fiber.
Okay, thank you.
So it's okay.
Afra, please ask question.
Thank you, Joy, for a nice talk. I have one question.
Okay.
That EcoSense uses sunlight to store it and amplify it, whatever it is. But I want to know what is the frequency range it is accumulating.
Frequency range, that means you are telling the how speed it is accumulating.
No, but is it our visible range or optical range?
It is visible. Basically, there's optical fiber. No, it can actually visible and infrared as well. Okay, because there's anything we have big parabolic mirror. Anything it will fall and reflected back. It will capture by sunlight. By the fiber bundle. Fiber bundle, especially silica fiber, it can send the light from up to 250 nanometer to infrared. Okay. So yeah, because of this infrared, actually we are getting much more heat.
Will it work for moonlight?
Actually, we saw in the full moon, but they are coming light, but it's not so powerful. No, that's why. But you can capture the sunlight. Yeah, moonlight. You can. Maybe in this case you need more big primary mirror. You understand? So you can capture more light, then you can see.
Oh, okay. Thank you.
You're welcome, Abdul.
Any question from participants? Please ask question.
Sir, I have
Mr.
a question.
Somen, you can ask.
Yes, sir, I have a question, sir. First of all, I would like to thank all of you for the beautiful presentation, sir. I have a question that in case of generating electrical energy, which is more preferable, the solar or the nuclear energy?
No, you see, again, there's a different field. Actually, we are talking about sustainable energy. Nuclear energy is not sustainable. You understand? Because nuclear, then you need to find again some uranium or something like that. Mine you need. It's kind of fossil fuel. But yes, nuclear energy can generate a lot of power. But still, it is not sustainable. So that's why people are thinking about solar energy. So you cannot compare with the nuclear energy with the solar energy in this prospect, because this is actually quite different thing, especially from the viewpoint of sustainability.
Thank you, sir.
One question.
One question is in chat box. Dr. Sai wants to know what is the efficiency achieved with the solar cells developed by your group?
Okay, actually we didn't develop solar cell. Maybe actually he misunderstood. Anyway, actually we didn't talk about the solar cell. Solar cell is a different field. Actually, we developed some optical fiber setup, concentrating light source that you can send the light. Actually, in this case, we cannot say the efficiency in this way, because if, like a solar cell, maybe you are getting 100 photons, you are converting in the electric current maybe 100 or maybe 80 or 50. It depends on efficiency, but here in this case there is no conversion. In our case, just capture the photons and send through the optical fiber. So yeah, it is not some kind of this efficiency like solar cell. Did you get it, or I need to explain more? Okay.
And I think no question from audience. I have not seen any question. Any question from audience? Please ask. If you have no question.
Hello.
Okay, please ask.
Can you tell me that your fiber system development of the fiber will be helpful in communication system?
Yeah, of course. They are same fiber now for the people are using for communication system. The people are using generally silicate fiber, okay, but not too much high quality that we use for our system. But yeah, you can. This same fiber, you can use it.
Okay. And can you repeat the daylight system in a nutshell, please? How can you store the sunlight in
No, you cannot
fiber
store.
optic?
No, in fiber optics you cannot store the light. Here I am telling it's not like a
They
solar cell that
now to gather the power of the sunlight.
Yeah, actually, we cannot store the sunlight using optical fiber. You can here actually what I told. You can capture the sunlight and instantly
Okay.
you need to send somewhere, like in your office, on your office building. You cannot store. This is the one disadvantage. Like solar cell, you can store as a electric power.
Yes.
You have battery, you can store it. But in our system, we cannot store it. You need to use it directly. That's why I told it daylighting. You can use it in the daytime during the sunlight.
Okay, that means in your country, that is Canada, it is more helpful.
Not like that. Canada is not too much helpful in that sense. Actually, in 4 5 months we have no sun almost, because there's too much cold. Minus
Okay.
40, minus 50. So we don't have any sun. So it is not helpful. In the summer is okay, but winter is all the year it is not helpful in Canada. So actually that's why we set up this instrument in the Brazil. There is a weather like India, so summer is summer, winter also there is lot of sun. So yeah, you can use all the time.
Okay. Okay. Can you tell me the reference of your literature paper published? How can I
Okay,
get it? How
actually
can I get it?
yeah, no, in the you can send me email. I can send you, because I think it is either you need to buy it from online. I can send you. If you can write me, I can send you.
Please tell me the email address.
Okay, in the message box, I am writing my email ID. Okay, so anybody, if you have any question or anything you have in mind, so you can just write me. Okay.
Okay.
Yeah, okay. I put in the messenger, okay? Yeah, in chat box.
Okay, thank you.
Okay, Ovik, please ask question. Ovik?
Dr. Raj, thank you for your wonderful talk. I want to ask you about this photocatalysis part.
Yeah.
So, can you use that to eliminate microorganisms from the water?
Yes, microorganisms. Some people are doing. We do, in our group we didn't do, but yeah, some people they are doing microorganism like some bacteria. They can degrade from the water.
Okay, thank you.
No, you're welcome.
So I think no question from audience. So once again, thank you very much, Dr. Rai, for your nice presentation, for wonderful presentation. So we hope you can join again, and
Yeah,
you
of course.
will
Yeah.
keep.
Yeah, of course. Thank you very much. And it is just a one message to audience. If you have any question or if any like your future career, if you want to do PhD or internship here in Canada in our institute, just let me know. Just write me an email. Okay. So I'll try for my best to help you.
Thank you very much. So today's lecture is ended here. Now tomorrow our webinar will start at 4 p.m. and tomorrow's speaker is Dr. Ujjal Das, Associate Scientist, University of Delaware, USA. He will deliver lecture on role of solar energy in sustainable development. So please join tomorrow or 15 minutes before at exact time. Okay. Thank you to all of you.